We already discussed what is stress and what is strain, different types of the stress and strains. Now we are discussing Hooke's law. Robert Hooke mentioned for the small deformations, the stress and strain are proportional to each other. This is known as Hooke's law. So stress is directly proportional to strain. So stress equal to K into strain, where K is the proportionality constant. It is known as modulus of elasticity. Now we are taking the stress and strain curve. What is the stress and strain curve? We mentioned already in the Hooke's law, stress and strain are proportional to each other, but only for the small deformations. And some of the material do not exhibit this Hooke's law at all completely. This time we are taking, so this stress and strain curve is not same for all materials. The stress and strain curve for metal is different, for wood is different. Here we are taking the stress and strain curve for the metal. This is the stress and strain curve for the metal. In this curve you can observe from a point O to A, when we are increasing the stress, the strain is also increasing linearly. So this equation or this straight line is like y is equal to mx. If x is strain, then y is stress. The stress and strain, they are linearly varying from the portion O to A. So in this portion, the metal is obeying the Hooke's law. Until the point A, the stress and strain are varying linearly. So the Hooke's law is getting obeyed. The point until which the Hooke's law is obeyed, this point is called as proportional limit, because until this point the stress and strain are proportional to each other. After this point, the stress and strain are not following the linear variation. From A to B, the stress and strain, they are not linearly varying. The variation is non-linear. But still until the point B, if we apply the stress and if we remove the force, if we are applying the force and if we are removing the force, the material can regain its original shape. That's why the point B is called as yield point. This is also called as elastic limit. Until this point, the material's elastic property is obeyed. After this point, the material is no more it is following the elasticity property. Instead of that, it is following the plasticity property. For a small changes in that material after the yield point, for a small variation in the stress, the strain will be varying so much. The rubber like these materials in this plasticity, they are when they are obeying for the small deformation, for small changes in the stress, there is a huge change in strain observed. So the yield point until which the material, even when we are applying the force, when we are removing the force, the material is capable of regaining its original shape. So that point is also called as elastic point we discussed, and the stress at that particular yield point is called as yield strength. That is the yield strength of material until which the material is capable of regaining its original form. Even if we are increasing the stress from the point B until D, the material is obeying the plasticity property. If we remove the force, the material cannot come back to its original form. After D, even still when we are increasing the stress, so the material gets fractured at the point E, and if this point D and E, the point D until which the material is obeying the plasticity property, and the point E where the material is getting fractured. If these 2 points are very close to each other, that means the material is brittle. If these 2 points are very far away from each other, that means the material is ductile. Based on the distance between these 2 points, we can tell whether the material is brittle or ductile. And as we mentioned, this curve is not same for the all materials. Now if we take a vessel or a elastic tissue in the heart that is carrying blood from the heart, then this is the stress and strain curve. It is not at all obeying the Hooke's law. because it is like a rubber tissue. These types of materials are also called as elastomers. So by seeing the stress and strain curve, we can tell until what point the material can come back to its original position. So this is very important to understand the behavior of the material, particularly to understand the elastic limit. This stress and strain curve is very much important to us.